Okay, thanks everyone for checking in to the chat. If you didn't already do that, go ahead and say you're here just so I've got that record of it. So how is everyone today? I'm cold. My office is a little chilly. Yeah, I think this time of year I always end up getting colder because of the change to cooler weather. Once I get used to it, it's not as bad. Plus, once the heat goes on in my house more, it's not as bad. So what's up, everyone? Do you guys have questions today?
Hey, can we do something with the last section? I couldn't get.
I'm trying to figure out what do you mean by the last section? Do you mean that section we were starting on last time with systems of equations?
I think it's linear regression.
Oh, okay. So the last section from the previous chapter.
Yeah, I couldn't get my calculator. I tried walking through them steps and it wasn't working for me.
Okay. All right. So on your calculator, shoot. First things first, you're putting your X's in list 1 and your Y's in list 2, right?
Yeah.
Oh, good. Cool. Great. You can show me.
This is a stat button, right? What was the button we have to press? Stat?
So if you go into stat and then edit.
Oh, yeah. I have it for a problem, too.
Okay.
I have a problem pulled up.
Perfect. Okay. So you got those in there. I want you to scroll down to the bottom of the list just so I can see all the way to the bottom. I just want to make sure of something because there's
Oh, shoot.
there is a possible little glitch in here. Okay, so do you see where underneath your 10 you have a 12 in the first list and then you don't have a Y value that goes with it?
Yeah.
That's problematic.
Okay.
So you need to, if that 12 belongs there, you need to put the Y value that goes with it. My guess is it doesn't belong there. So
No.
you need to go over and just highlight that 12 and hit delete and get rid of it.
This is the delete button, right?
Yeah, so with it highlighted, you should be able to hit, okay, try delete and now hit enter.
Oh no, it took me to another line.
Okay, so arrow back up and try the delete again right there. Okay, now look at it.
Oh yeah.
Okay, now try all the other steps again. You were getting a dimension error because you had more things in one list than you had in the other list.
Oh, okay.
So they have to be balanced. It won't just ignore those extra things. It will say, oh, you don't have a Y value to go with this. I can't do it.
Okay.
So try that again with those, and I think the steps on that sheet should work now.
Can I bring up the problem?
Sure. Yep. Go ahead.
It's this one right here.
Oh, perfect. Thanks for sharing your screen, Dakota. That's helpful. And we can do it with holding it up, but this makes it nice and easy for all of us to see. Okay, so you got all those X's and Y's in there now. Okay, so now you're going to go, what do they want us to do? Round values of A and B to the nearest hundredth and use the equation to solve for Y when X equals 12. So we're just putting in a final result when x equals 12. And I think that's where you got the 12 from in there. That's what kind of messed you up.
Uh-huh.
So the first thing we need to do is find the equation. Then we'll be able to plug in the x equals 12. So go back to your calculator.
All right.
And you are going to, you're going to go to stat. Let's see if I give you the steps, if you can do this. I think we can do this. You're going to go to stat, and then you're going to go over to calculate, C-A-L-C.
Mm-hmm.
And you're going to go down to number 4, which is linear regression.
Yep.
And hit enter. And that should bring it back up on the home screen. Yep, and now he just hit enter one more time. Okay, so now you've got your equation, y equals ax plus b.
All right.
So it's y equals 0.96x plus something. I didn't see it all. But they wanted you to round to 2 places. So you're going to have like y equals 0.96x plus, what is that number?
1.655. Yeah,
1.66. Okay, so now you've got that equation, and just write it down with the 2 decimal places.
All right.
And you don't want to put that in your answer on the problem, because what they want you to do now is plug in x equals 12.
Okay.
So now you can just go off and plug in 12 for x and do that computation, and you'll get your y value.
Okay. So it looked like that.
So yeah, and let me pin your video so I can. Yes, and then hit enter, and that should be your y value to 2 decimal places. So we're going to find out. Yay. Okay, and there's a lesson in there for everybody. I think Samantha and I were working on problems like this last time. And one thing that you need to do when it says round to 2 decimal places, you're going to round first and then plug in the number.
Okay.
As opposed to plugging in the number and then rounding in order to get their answer.
Okay. And is this whole section going to be like that?
It's going to be very similar. In some of the problems, they'll ask you for the equation. So if they ask you for the equation, you would have entered the 0.96, the y equals 0.96x plus 1.66.
Okay.
Okay, so some problems they'll ask you for the equation. Some problems they'll ask you to find x or y given the other one.
Okay.
But they're all very similar, yeah.
And thank you.
You probably won't have to do too many of them.
Perfect.
Once you do a couple more right, it'll decide that you know what you're doing.
Right.
Okay. Unpin that. There we go. Okay, other questions? That was a good one. We kind of keep popping back to those. I think a couple of you are struggling with them. So if you're still having issues with regression, go back and check those instructions for using the TI, or go back to the instructions that we did in class a couple different times for using Desmos, because you can do those in Desmos as well. Other questions? Oh, yep, I sure can, Jenna. I see your question now. How to find the equation of a line that can't contain certain points, and they give you a couple points. This is another good question for our project coming up, because I am going to ask you to do this by hand on there, and then ask you to do some things with the calculator or with the computer. So let me share my whiteboard. And let's see, I'll even do your 2 points, Jenna, that you gave me. Is this one of your problems that you came up with in your?
It's on the homework.
Yeah, so we've got the points -4, 8, and 7, negative 6. And we're just trying to find the equation of the line that passes through these guys. Remember, if we want the equation of a line, we need the slope, and then we need at least one more point. So we don't have the slope yet, but we have 2 points, so we can get the slope. And we can use either form for the equation of the line to do our work. We can either use the y equals mx plus b form. That was the one that looked like that. Or we can use the point slope form, which was y minus y1 equals m times x minus x1. So this one is called slope intercept. And the second one is called point slope. And which one you use is kind of a matter of personal preference. I usually use the bottom one, but you don't have to. You can use the top one if you like it better. What you have to do is make sure you get all the way to the final answer and report it. So let's see if we can find the slope. Remember, our slope formula was the difference in the y values over the difference in the x values. This is telling us how steep the graph is, the rise over the run. So we're going to subtract, and it doesn't matter which one we call the second point, but we have to be consistent. So I'm going to say negative 6 minus 8 over 7 minus negative 4. And it looks like the numbers are a little bit messy here, but I get negative 14 over 11. Is that what you came up with on that, Jenna?
Yep.
For your slope?
Yep.
Okay, good. So you got that far. Then now tell me, since this is one you were trying to work on, which one of those two formulas did you use, or did you just stop here and not get that far?
I used the bottom one and it just keeps tripping me up.
Okay, so let's see if we can figure out where your error is. I'm going to write the formula down. Y minus the y coordinate equals slope times x minus the x coordinate. All right, and I can use either point. So tell me, did you use the first point or the second point?
Honestly, I tried both.
There's the problem. So I hope you tried them one at a time. You can't put them, okay. So, let's just use the first one. It's there first, so we'll go ahead and use it. Y minus 8 equals negative 14/11 times x minus negative 4. So did you get to that somewhere in your work?
Yes, I did.
Okay, good. Well, then that means that you're not making big time algebra mistakes. You probably just have a little bit of arithmetic mistakes in here or something. So maybe these fractions are tripping you up.
Yeah, fractions suck.
Okay, so I'm going to distribute that negative 14/11. And I'm also going to notice that since this is a minus negative 4, it's actually plus 4. Does that make sense?
Yep.
Okay, so negative 14/11 times positive 4 is negative, let's see, I'm going to just jot this over here to the side. And you can do this on your calculator if you want. Just use the math, turn it back into a fraction command when you're done, and it will give you your answer as a fraction. So this is negative 56/11. Did you come up with that?
No, because I didn't know that I could use my calculator for fractions.
Okay, but also remember how we multiply fractions. So the 4 is really 4/1, right? And we're going to multiply numerators and multiply denominators. So negative 14 times 4 is negative 56. And then 11 times 1 is 11. But if you did that on the calculator, after you do the calculation, just hit the math command, and then number 1 says, there's a little arrow and says FRAC. That changes your answer back into a fraction for you. So that's a handy little thing to remember how to find on the calculator when they want exact answers. Can you find it now?
Yeah, that's pretty
Okay,
much my
good.
only problem.
All right. So now we're going to add 8 to both sides. And if I were doing this by hand, I'm doing -56/11 plus 88/11. But you could use your calculator. And I get 32/11. So I'm going to write my answer as -14/11 x plus 32/11. Now, you do want to be a little bit careful sometimes. So that form for our answer that I'm showing you right there is called the slope-intercept form again. This tells me the slope is -14/11, and it tells me that the y-intercept is at 32/11, so almost 3, just a little bit below 3 if I were to graph this. If they ask for standard form, did you run into any like that yet?
I didn't know.
Okay, if they do ask for standard form, you need to clear the fractions and then put the x and y on one side. So I'm just going to show you what that looks like in case you run into some of those in the next few problems. So I'm going to multiply everything by 11 because that will get rid of my fractions, right? And I'll have 11y equals -14x plus 32. Standard form has the x's and y's together on the same side. So I'm going to add 14x to both sides. 14x plus 11y equals 32. So that form is what we would call standard form. And if they ask for your equation in a specific form, you want to make sure that you give it to them that way. If they had asked for point slope form, we would have left it right here. And if they asked for slope intercept form, that was what we had at the bottom of the page. If I were giving you a handwritten test, that would be the way I would ask you to write the answer almost all the time, slope intercept form.
Awesome, thank you.
Okay, you're welcome. And that should help you on some others because they're going to be similar, right?
Yep.
Okay. Any others? So Dakota and Jenna came with good questions today. Our test is due today, right? That is correct, I think. Let me just go take a peek. Keeping track of all my, not that one. Let's see. I'm gonna get to the right course, intermediate algebra and test. September 30th, that's today, that's right. Okay, and it looks like several of you have it done. So, yep, test number 2 due tonight. It does have a 2-hour time limit. That was my plan originally. I think the first one, somehow the time limit didn't get in there, so you might have gotten to use a little bit more time, but you should have plenty of time to finish. Okay, other questions? that's just a blank page in case somebody else has another question, but I can go back if anyone needs to still see that. Okay, so the rest of this week, the new material continues with systems of equations, and the systems of equations stuff is not on that test. So that goes through, as I think Dakota mentioned, the last section for the test is the linear regression stuff. So make sure you've got that down with your calculator or with Desmos so that you can do it when you need to on the test. And then we moved on and we looked a little bit at systems of equations last time. So what I'm going to do today now is I'm going to give you another problem, and I'm going to ask you to solve it using the addition or the elimination method. So you're going to try to solve it. In fact, I think I might see if I can. Yeah, I can today. I'm going to send you guys off into breakout rooms to try to work on a problem. I'll just put it up on the whiteboard so that you can see what it is and get it written down. And then you can try to work through it. This one's going to have a couple more problems to it, or a little bit more interesting info in it than the ones we did before. And then we're going to look at some applications, and we're going to look at stepping this up a level to 3 variables. Then next time we're going to look at using matrices to solve. So this is going to be very calculator and computer related. So we're going to want to be able to access technology next time for sure. Okay, so let's just make up a problem, and I'm going to go with 7x, that sounds good, minus 8y is -9, and let's go with 3x plus 2y equals 7. So we've got a system of 2 equations and 2 variables. We want to solve the system. And remember, solving the system means that you're going to look for both the x and the y that satisfy both equations. And I want you to solve using the elimination or the addition method. Those were 2 different names for the same thing. The elimination, that was the one where we tried to add the equations together to get rid of a variable. Hence those 2 names. And let's see, we're going to do more. We're going to go breakout rooms. 9 participants in 2 rooms. One of them is probably me. No, not 1 room. Let's go 3 rooms. Okay. So you guys should be in breakout rooms, and you should be able to get into them. And I should be able to pop in and see how you're doing. Okay, and the other me is not going to join, so we'll have 1 less person. This is really interesting because everybody disappears from the main room. Hey, Megan and Beverly.
Hello.
Hello. So I just want you guys to try to do that problem. If it's not convenient for you guys to try to do it together, it's okay to just kind of work on it on your own, but then maybe you can just share with each other what you got for your answers and double check each other's work when you're done. And if you're able to work together, that's okay too. So I'm going to pop out and jump to another room. Hey, Ashley and Dakota.
Hey.
Okay, so if you guys can work together, go ahead and do that. But if you can't, if you could even just maybe share screen with each other or share info to see if you can help each other figure out what you're doing. So see if you agree on the answer.
When the thing popped up, I pressed join too quick, and I didn't write the problem down.
Okay, I can tell you what it is.
Okay.
All right. The first equation is 7x minus 8y equals -9.
Okay.
And the second equation is 3x plus 2y equals 7.
Okay. Thank you.
All right. No problem. Hi, Tirza and Cody.
Hi.
Cody, are you the only one here?
Yeah, I think so.
Well, I had 3 people in here at one time, and then they've popped in and out. So I think Tirza might be having trouble with getting in.
Yeah, I think so
This
too.
wasn't that great of an idea. But while you're off in this room, since you're the only one here, if you want to just go back to the main session, you can. I just want you to work on that problem.
All right.
And if someone joins the room with you, you can work on it. I could always reassign you to a different room so you can check in with other people too. I might do that. Let's see. Oh yeah, you're the only one here other than me. I'm going to move you to room number 2 because they have 2 people there. Okay, we'll go back to recording. All right, so did anybody come up with a solution?
Yes.
Who said yes? Was that you, Ashley?
Megan.
Oh, Megan. Okay, what did you
I
come
got
up
like X is for 1 and then Y is for 2.
Okay, that's what I get. And I didn't do the problem yet. I just made up the answer when I made up the problem. So I just kind of plugged in 1 for X and 2 for Y and then calculated what the right-hand side should be. So let's show everybody how to do that because I'm not sure. In fact, I'm pretty sure that at least some of you didn't get that far. Can you tell me what you did first, Megan? Just to get us started. I'm going to label these, which probably isn't what you did first, but I'm going to label these like equation 1 and equation 2, just so we have reference. And this is going to be a little bit more important in the later problems because we're going to do these with 3 equations and 3 variables. And so if we can kind of keep track of which one is which, then that'll help us a little bit. So let me see. Okay, just double checking there. All right, so we want to eliminate a variable. And we can pick either one. In the problem we did last time, it was set up really nicely because I think the first equation had like a plus y and the second equation had a minus y. So when we added them together, a variable was eliminated for us. In this problem, we don't have that. We've got a minus 8y though and a plus 2y. So tell me what I could multiply the bottom equation by to get rid of the y's. What
4.
number? What'd you say?
4.
4. Yeah, so what I'm going to do is I'm going to take 4 times the second equation. And I'm just going to write that as 4 times the 2 with the circle around it. So that means the equation, not the number 2. So that gives me 12x plus 8y. And we have to multiply everything by 4, so 28. And then I'm just going to recopy my first equation. 7x minus 8y equals -9. That's really an ugly looking line. And then I'm going to add those together. And I get 19x. And notice that the -8y plus 8y adds up to a big fat 0, so that's gone. And 28 plus -19 is me copying the problem down wrong. That wasn't -19, that was -9. 28 plus -9 is 19. I think I was jumping ahead to the next line. And then we can divide by 19 to get x equals 1. So Megan said she had 1 for x, so that looks good so far. And then we're just going to go back and we can plug into either equation. I'm going to pick the second one because it has smaller numbers in it and no negative signs. 3 times 1 plus 2 times y equals 7. And that's 3 plus 2y equals 7. So -3 minus 3, 2y equals 4, and y equals 2. So 1, 2 is my solution, and that's how I would write it. I would write it as an ordered pair. And we can check. Notice if we do 7 times 1 minus 8 times 2, do we get -9? 7 minus 16 is -9. That one's good. And 3 times 1 plus 2 times 2, we want to make sure that's 7. 3 plus 4, yes it is. So we can always check back in the original equations and come up with our solution. Does that make sense? All right, let's try an application. You guys love the application problems. Just do a new page. And I'm going to kind of make one up on the fly here. And it'll be similar to some that we saw before. Let's do one of those ticket problems. We did several of those, and I think they gave us a little bit of struggle. Let's say that tickets to a show are, we'll make this fairly inexpensive, $5 for adults and $2 for children. If 100 tickets were sold for a total of, let's see, $275, how many of each type were sold. So $5 for adult tickets, $2 for children. We've got 100 altogether and a total of $275. So this is a problem that we could actually do back in the earlier chapter where we had just one variable, but it turns out that it's a little easier to set up with two variables. So that's what we're going to do. We're going to start by just assigning our two variables. We'll let X equal the number of adult tickets. And we'll let Y equal the number of child tickets. Now, since we have two variables, we're going to have to come up with two equations. And essentially, we're going to have one equation that relates to the number of tickets, and then a second equation that relates to this total amount of money, the $275. So can you guys come up with one equation for X and Y that goes with the 100 tickets? What would you do with the X and the Y values to come up with 100? What would have to happen there? You guys are so quiet. What if I said there were 60 adult tickets? How many child tickets would there be? 40. Notice you picked the number that you got when you took 100 minus 60. Or another way to say that is that you picked the number that added to 60 to give you 100. So whatever my X and Y values are, they have to add up to 100 tickets because I'm just selling child and adults. You know, I suppose I could expand this to a bigger problem and have senior tickets also, but I didn't do that here. So my first equation is for the number of tickets, and it says X plus Y has to be 100. Whatever those numbers are, when we add them together, we're going to get 100. The second equation is going to have to do with the money that I make. So let's go back to that $60 adults again. If there were 60 adults, how would I figure out how much money I made on just the adult tickets? What would I do with that 60?
Would it be times by 5?
It'd be times by 5. But there aren't 60 adults. There are X adults. We don't know what X is yet. So we're going to multiply it by 5. 5X is going to give me the money that I get from those adult tickets. What will give me the money from my child tickets?
2.
2 times what?
Y.
2 times Y. So 5X plus 2Y gives me all my money, and all of the money that I collected was $275. Then to solve this, I'm going to say, okay, well, here's my first equation. And we'll number these again. In order to eliminate a variable, I can decide to eliminate X or Y, and it's totally up to you. I like to keep numbers smaller, so I'm going to eliminate Y, and I'm going to do that by multiplying this equation by -2. So notice when I multiply by -2, I get -2X minus 2Y equals -200. And I'm going to leave that second equation alone. 5X plus 2Y equals 275. So here's this elimination method again. We're going to add these guys together. 3 times X. There's another big 0, so that goes away. 3 times X equals 75. And this even came out nicely. X is 25 adult tickets. And if there were 25 adult tickets, how many child tickets must there be?
75.
75. And a quick check of this. Let's just take a peek. Remember, we sold the adult tickets for $5 each. So 25 times $5 per ticket is $125. And 75 times $2 per ticket is $150. And if I add those together, I get $275, which is right. So we know we did it right. So it's really kind of the same type of problem we had before, but just sort of moved to this 2 variable scenario where it might be easier to figure out how to solve the system of equations, that rather than setting up a single equation to start with. Let's try another one. And this one, I'm actually going to even add a 3rd variable. So this one's going to require 3 equations, 3 variables. And we're going to go with a triangle. So we'll do a little scenario of a triangle. And this triangle is definitely not necessarily drawn to scale. So it's just so that we have something to reference to label. And let's see, the second side of a triangle is twice the first side. And the third side is 3 less than the first. If the perimeter is, I should probably try to make this come out nicely. Let's see. If the perimeter is, we're going to go 13 inches. We're going to try to find the length of each side. Okay, so we could have done this problem back again in the 1 variable scenario, but let's see if we can do this with 3 variables. So I'm going to call these X, Y, and Z. So I want you to first start out by giving me an equation from that statement. The perimeter is 13 inches. I want an X, Y, Z equation for that. Who's got one? What did perimeter mean again? It was the distance all the way around. So what would we need to do with the X, Y, and Z? I'll give you 4 choices. Add, subtract, multiply, or divide. X, Y, and Z. Are they going to add up to 13 inches? There's one equation. Now, We didn't really say which one's the first side, which one's the second side, which one's the third side, but let's just do them in order. First, second, third. And again, remember my picture wasn't drawn to scale. It was just so that we have something to reference. It says the second side is twice the first side. So how would I write that? That's y and x. If you think you know, go ahead and type it in the chat. See what we can come up with. Any ideas for an equation that relates this information? The second side is twice the first side. So I'm not trying to get everything at once, just that bit of information.
X plus 2y.
X plus 2y. Well, I definitely need a 2 times something, right? The other thing to remember is this word. What does is mean mathematically? What do we usually think of when we say something is something? What's the symbol there?
Equal.
Equal. So the second side, I'm going to just take this very literally. The second side, which one did I call that? I called that y, right? Is equals, it's going really slowly, twice the first side. How would you write twice the first side?
Is that 2x?
X? Yeah. So there we've got it. It's actually y equals 2 times x. So now I've got my second equation, y equals 2 times x. Notice this isn't written in the same form as that first equation. That's okay. This is actually written in a nice way to use our substitution method to solve. The third side, let's switch colors. We'll go to green. The third side is 3 less than the first. So the third side, we called that z. We said is says equals. And how do I do 3 less than the first? 3 less than x.
X minus 3.
X minus 3. Good job. And that was important. That order of subtraction matters, right? 3 less than a number is the number minus 3. So there's my third equation. Z equals x minus 3. Now on this one, I'm going to use the substitution method. X plus y, but y is 2x, plus z, x minus 3, equals 13. So there's my equation. Now, we could have probably done this one without using the extra variables, but it kind of gives us that idea moving into the 3 variable case in a not so horrible problem. I'm going to add my like terms. 4x minus 3 equals 13. Then I'll add 3 to both sides and come up here. So 4 times x is 16 and x is 4 inches. Let's see if we can find the other values. Y is 2 times x, 2 times 4, 8 inches. And z is 4 minus 3, or 1 inch. And our quick check on this one is to make sure that the perimeter is right. 4 plus 8 is 12, plus 1 is 13, so that looks good. If you were writing this as an ordered triple, it would be 4, 8, 1. And we just solved a system of 3 equations in 3 variables, and we use the substitution method. We will often want to use the elimination method just like we did on that 2x2 system earlier, because things can get messy if you try to substitute with more complicated equations, since you can often end up with fractions. In this case, we didn't have any fractions to deal with, so it was kind of nice. So tell me, let's see, actually I'm going to do a new page, and let's just go back to another problem. So this is going to be a 2 by 2 system again. 2x plus 5y equals 10, and 5x minus 3y is -6. So how many of you had solved problems like this before this semester? So before we started looking at these last time? How many of you remember seeing these? Give me a yes in chat if you've seen problems like these before. You can give me a no if you've never seen a problem like this before. Give me a yes if you have, a no if you haven't. Looks familiar, says Dakota, but he's not going to completely commit to a yes. Megan says yes. Ashley says no. Todd says yes. Tirza says no. So we've got some definite yeses, some definite no's. Dakota's in the middle on this, and maybe he's seen it, but it's not too familiar. So this is really, again, another problem like what we had last time. This one's a little bit funkier because notice that if we try to get rid of the x's or the y's, we don't even have a number that divides in evenly to the other number, where we could maybe just like multiply one equation by 2 and cancel things out. And we really want to avoid fractions if we can. So what we're going to do is we're going to still stick to this elimination method, and we're going to think about these things the way we think about fractions in a way. So I'm going to pick a variable, and just because it's a little bit more convenient with the minus sign, I'm going to pick the y variable. And I'm going to look at this. I'm just going to circle this. This isn't as big zero before, like before. And I'm going to try to think about how I could get the y's to cancel without using any fractions. So tell me what number, just a single number, 5 and 3 both divide into evenly. In other words, what's the greatest common multiple, or least common multiple of 5 and 3? 15. Thanks, Dakota. So 15 is my goal. And to get to 15, I'm going to multiply the first equation by what? 5 times what would give me 15? 3. And in order to get to 15 in the second equation, 3 times 5 would get me 15. So I'm going to multiply the top equation by 3, the bottom one by 5. A quick note, if I didn't have that minus sign there, I would multiply by a negative number so that I could change the signs everywhere. Let's see what we get when we do this. 3 times 2x is 6x. 3 times 5y, 15y, equals 3 times 10, 30. And then similarly down below, 5 times 5x, 25x. 5 times -3y, -15y. And 5 times -6, -30. So now I got exactly what I wanted. I got my 0 here, and the y's will cancel and go away for me. So now 31 times x, well, that's a little bit ugly, equals 30 minus 30. Oh, that's 0. That's nice, because x is now what? X is equal to, what's the only number
0.
that I can, yeah.
0.
Yeah, Because 0, remember, if you divide by 31, 0 divided by anything is just plain 0. Well, this is going to be nice for substitution now. 2 times 0, that's just 0, plus 5y equals 10. So 5y equals 10, and my y value is 2. 0, 2 is my solution. And there's my ordered pair notation again. Are you remembering these a little bit more, Dakota, as we do them?
Yeah, I am.
Ashley, really no? Or maybe you've seen them? Kinda, okay. So I'm glad I jogged a little bit of memory. I'm gonna give you guys one to try, and we're gonna stick with 2 variables again. We're gonna move up to 3 variables after we do one more problem with 2. So what I'm gonna do is I'm gonna put another problem up on the whiteboard. I just want you to try it. We're not gonna go back to the breakout rooms. It's too funky for some of you. And I think you can just, there are a few enough of us in here that you can talk together if you do want to talk and ask questions of each other. Or you can type into chat if you want to check with each other on what you get. So let's add a new page and let's make up a new problem. I'm going to go 7x plus 2y equals 5 and negative, no, not negative. We'll go 2x plus 7y is also, no, is negative 5. Yeah. Okay, so see if you can solve that for x and y. I'm going to take a break on the recording and run and get myself some water or maybe some more Diet Coke, although I probably should. Okay, so you must have remembered enough, Ashley, because you got the problem right. Right? Can you guys tell me what you did? Did you multiply one equation by 7 and the other one by 2?
No, I was just looking at it. I'm like, well, if I had a positive 7 and a negative 2, I could get 5. And I was just kind of,
okay, so you kind of did it by guess and check.
yeah.
Because I made the numbers kind of nice. Okay, so let's see if we can do this. I'm not going to say the right way, but sort of the regular way, because if the numbers aren't so nice, you might not be able to just guess them, right? So here's how I would have gotten to that. I would look at my numbers, and I have this 2 and this 7, and they don't have any factors in common. So I'm thinking least common multiple again is 14. So I'm going to multiply the top equation, and you can actually pick either one. We've been eliminating y, but there's nothing magical that says we have to eliminate y. So this time I'm going to go ahead and eliminate x. I'm going to multiply the top equation by 2. And the bottom equation, a little bit differently, I'm going to multiply by negative 7, not positive 7. You'll see why in just a minute. So when I multiply the top one by 2, I get 14x plus 4y equals 10. And when I multiply the bottom equation by negative 7, I get negative 14x. Notice I wanted that negative with the 7 so that those two numbers add up to 0. I want them to be the same but with opposite signs. And 7 times negative 7, negative 49y equals 7, negative 7 times negative 5, positive 35. And then I'm going to add these guys together. This time my x is 0 out. And I get negative 45y equals positive 45. So when I divide by negative 45, I get y equals negative 1. So you did some good guessing there, Ashley. And now I'm going to go back and substitute 7x plus 2 times negative 1 equals 5. So 7x minus 2 equals 5. 7x is 7 and x is 1. And you are right, 1, negative 1 was the solution. Megan, did you do the problem using algebra similar to what I did, or did you just guess and check like Ashley did? She's not going to tell me. You know, she's here somewhere. Okay, so the next thing that I have for us is to look at systems with 3 variables. And I know none of you are really here to this point yet, but we're going to try to do one problem before we go today. And then we'll probably end a little bit early, or you guys can just keep working on some problems and I'll hang around and answer your questions if you have any. But I want to give you a flavor for one so that when we get into them on Friday, we'll be all ready to do them and all set for them. So let's go ahead and do one more. So this one's going to have 3 equations, 3 variables. And we're going to start with a relatively nice equation. I'm just going to go x plus y plus z equals, let's go 6. And then I'm going to go x plus 2y minus z equals 2. And finally, 2x plus y plus 2z equals, let's see, 10. Okay, so other than the fact that this looks scary because there's just so much stuff going on here, the numbers don't look too horrible because the largest number I put in here was a 10 and I didn't throw in any fractions. So the idea might be that you have 3 things that are related to each other, and those 3 things have this, this sort of relationship where the sum of the numbers, the sum of a couple minus something is 2, and something else adds up to 10. So our goal is, again, to figure out what all the numbers are. And if we get lucky, maybe we could just go in there and say, oh, the answer is, 1, 1, 1. Well, that doesn't work. 1 plus 1 plus 1 is not 6. So we know that's wrong. And we could keep going, but we're going to just try to do this in sort of a nice way that's predictable, that will work even when the answers aren't nice. Okay, so we're still thinking elimination. And here's essentially what we're going to do. We're going to start with our 3 equations and 3 variables. We're going to get rid of a variable and we're going to move this down to 2 equations and 2 variables. And then we're just going to solve that like we did before. And then we'll be able to go back and substitute to solve for the 3rd variable. So our goal is to take this sort of bigger problem that has an extra equation and an extra variable and smush it down into something we already know how to do. I would claim that this problem isn't really any harder than the other one. It is longer, which I suppose means there's more chance for error, but it's really not harder. It's just longer. So this time it's going to be really important to have these labeled, and I'm actually going to label them this time. Let's call them equation A, equation B, equation C. So looking at these three equations, can you guys see one variable that you could eliminate by just adding two of the equations together? In other words, would something nice happen if you added just two of the equations, and if so, which two?
The A and B.
The A and B. Notice that if you add them together, you eliminate Z. So that's what we're going to do. And by using A and B first in this way, we've decided, at least in this problem, that we're going to eliminate Z first. And that's important because we're going to have to stick to that. We're going to stick to our guns on eliminating Z. Okay, so to do that, I'm going to take equation A and I'm going to add it to equation B. And that's going to give me a new equation. That's going to give me 2x plus 3y. Notice the z's cancel, equals 8. So there's a brand new equation that only has two variables. And we are well on our way. We're going to give it a name. We're going to call it equation D. Now, we decided to eliminate Z, so we have to eliminate Z again. So my next line is going to say, use equation C. We haven't used it yet, so we know we need to. So I'm going to use C along with another equation. I'm going to use C along with B. Notice that if I add them the way they are right now, nothing's going to cancel. So what should I multiply equation B by? Let's see, I've got a minus Z here and a 2Z there. So I could multiply equation B by 2. Let's write it down so you guys can see. If I multiply B by 2, I get 2x plus 4y minus 2z equals 4. And equation C, I'm just going to recopy. 2x plus y plus 2z equals 10. And I'm going to add those guys together. Something equals 14. Notice the z's cancel. And I have 4x plus 5y equals 14. So I don't need to rewrite it, I don't think. We'll just label it. We're going to label that one E. So now I have two new equations that each have two variables, and they're the same two variables. They both have x and y in them. We eliminated the z's completely from those two equations, and we know how to solve this because we just did it. So let's jot these up here again. 2x plus 3y equals 8, and 4x plus 5y equals 14. We're back to a 2-by-2 equation. If I were to erase everything else on this whiteboard, you guys could figure out how to solve this. you'd say, well, maybe I could eliminate X or Y, your choice. I would probably eliminate X since I can do so by just multiplying the top equation by what number? Would I get rid of the X's? I have a 4X here, so I want to get to a minus 4X. What do I need to multiply by? Negative 2 minus 6y equals negative 16. The second equation is just going to stay the same. And these numbers were starting to look a little big, but notice what happened here. There's a 0. Negative 1y equals negative 2. Divide by negative 1, and y equals 2. Once we get to this point, we're really close to our solution, because at this point, all we need to do is some substituting. We're going to plug in our y equals 2. 2x plus 3 times 2 equals 8. So 2x plus 6 is 8. 2x is equal to 2, and x is 1. Now I have x, I have y. I'm going to go back to, in fact, let's label this. This was equation D. And I'm going to go back to equation A. It said x plus y plus z equals 6. So 1 plus 2 plus z equals 6. And z is 3. And there's my solution. X is 1, y is 2, z is 3. We should be able to double check and make sure that those fit all 3 equations. 1 plus 2 plus 3 is 6, so we're good there. Let's see, what else do we have? Let's see, 1 plus 2 plus 3 is 6. 1 plus 2 times y, so plus 4 is 5. Minus 3 is 2, so that's good. 2 times 1 is 2, plus 2 is 4. 2 times 3 is 6, 4 plus 6 is 10, so they all check. So remember, you can always check these problems by going back to the original equations and making sure that they fit. So that one was a little longer. And I don't want to do any more of those today until you guys have had some time to practice both the 2x2s and the 3x3s. So I think I'm going to leave it right there unless you guys have questions. Are we good? If we're good, you can go, or you can hang out and work on homework, and I'll stick around and answer questions for you. Dakota and Todd, you guys both okay? You have a good day too, Dakota.
Yeah, I'm just gonna stick around and work on some homework.
Okay, perfect. I'm gonna leave from my iPad.